you so much. Thank you so much for the introduction. Thank you so much for having me, and welcome to Adaptive Socio-Technical Systems with Architecture for Flow. And first of all, kind of heads up, I will talk about a lot of content, so it's very information heavy, but I will provide a link to my slide deck at the end of the presentation. And also, yes, as already mentioned, I'm writing a book about it. So if you're interested in explore more about the topics, there will be a book out. So it's still, I don't know when exactly it's going to be published. It has a long title, so I prefer the shorter subtitle, Architecture for Flow. So can you guess what these companies have in common? I hear some laughter in the audience. Well, these companies have in common that they don't exist anymore, or at least not with their original core business. So all of these companies filed for bankruptcy or sold their core business. So, but why? What was the reason for those companies to shut down or selling their businesses? And the major reason were their failure to adapt. So those companies failed to adapt or keep up with new or changing circumstances, so that they were forced to file for bankruptcy or selling their core business in the end, which led to massive job and financial losses, not only in the US, but also worldwide. So in today's fast-paced business environment, it's essential for organizations to continuously adapt and to evolve to remain competitive and stay relevant in the market. Now the question is how to design systems that can evolve and thrive in the face of constant change. One approach is to tackle the situation from a rather holistic view and combine various perspectives. So on the one side, it requires to understand the business landscape an organization is operating and competing in, and also understand the external forces that impact this landscape. It also requires to generate a common understanding or shared understanding of the problem domain in order to build and design a system that is closely aligned to the business and user needs and to the business strategy. And it also requires to align not only the technical solution, but also align teams and the interaction and evolve their interaction to the system we build and the strategy we plan. Or with other words, one approach out of many could be connecting the dots between Wardley Mapping, domain-driven design, and Team Topologies. So let's start with it, and let's dive into, or let's demonstrate this approach by evolving a legacy system using an example of an online school solution for junior students. And we can start, for example, with gaining a common understanding of the business landscape by creating a Wardley Map. And a Wardley Map is visualizing the landscape of an organization. And a Wardley Map is part of Wardley Mapping, that is a business strategy framework invented by Simon Wardley. So who of you have heard of Wardley Mapping before? A few hands up, 15.99%, I would say. So, and so a Wardley Map itself is just one part of Wardley Mapping. And when we create in Wardley Map, it's essential for organization to know the users and their user needs. So they are representing the anchor of our map, and they are the subject area for which we build a product. And the user and the user needs, they are directly or indirectly fulfilled by a chain of components generating value for the user, representing the value chain, the y-axis of our Wardley Map. And the components of the value chain, they are typically mapped to evolution stages. So from genesis at the left with brand new things, then custom build, then product and rental, such as off-the-shelf products, open source software solutions, and commodity and utility at the right. And each evolution stage comes with different characteristics. So towards the left spectrum, towards Genesis, we are dealing with high change rates. So the components are changing far more frequently on the left part of our Wardley Map than on the right part towards commodity and utility. Towards commodity and utility, the components become more stable, widespread, known, standardized, and the markets are mature and well evolved. While on the left side, we are dealing with high level of uncertainties, undefined, poorly understood market. And the Wardley Map itself provides a structured way to discuss and generate a common understanding of the landscape within a group. And also, it helps us to challenge our own assumption while we create this Wardley Map together in a group. And the Wardley Map itself helps us to identify areas where we can potentially innovate, where we can improve efficiency, or where we can outsource in order to gain a competitive advantage. But that also requires, before we do this, it also requires to understand the external forces that are impacting our landscape. And that's where we come to the climatic patterns. So climatic patterns are describing external forces that influence our landscape over which we have no control. But however, understanding climatic patterns gives us an idea, or is important when anticipating change, according to Simon Wardley. So understanding climatic patterns gives an idea where the landscape can change and where to invest in the future. So Simon Wardley has created a collection of roughly 30 different climatic patterns. We are not going through them, just only a small selection. So one pattern is that the landscape is never static but very dynamic. So everything evolves from left to right through the forces of supply and demand competition. So, for example, cloud-hosted services reflect this climatic pattern. What was decades ago non-existent evolved through Genesis, custom build, product and rental, and now is available as commodity and utility. Or large language model evolved thanks to competition-driven technology advancement and are now available as product. And the standardization and industrialization of components increases efficiency. And that brings us to another climatic pattern of efficiency enables innovation. So the industrialization and standardization of components and the efficient provision enables the innovation of others. So that it enables that new features of existing products can appear, or that other components can co-evolve, or that new components can emerge. And it's the genesis of new components that enables new user needs, creating new future source of value as another climatic pattern. So understanding the landscape and the climatic pattern that act on our landscape help us to understand, anticipate opportunities from a business strategy point of view. And it helps us to give us an idea where we can, or to identify areas where we can potentially change, where to invest, and so on, so to gain competitive advantage. But before applying those changes and those investments, we also need to assess how well we as an organization are equipped to respond to changes quickly, and how gracefully we can absorb changes themselves. And that requires to look at our system as a whole rather than isolated parts. So Dr. Russell Eckhoff, one of the pioneers of the system thinking movement, stated that a system is more than the sum of its parts. It's a product of their interactions. And the way parts fit together determines the performance of a system, not on how they perform taken separately. And that reminds us to analyze the dependencies between the parts of our system to assess our responsiveness to change. So from an architecture point of view, we need to analyze how the parts of our system are coupled together. For example, in our example, we are dealing with a monolithic big ball of mud with a messy model and no clear modular boundaries, which leads to tight change coupling. And with tight change coupling, it is impossible to modify one part without impacting other parts of the system. So, and yeah, without changing other parts of the system, and also introduce a high risk to break things in other parts of the system. And with business logic mingled together in a messy model, it takes a high amount of effort to understand a piece of code. And with fuzzy boundaries, it's really difficult to establish clear ownership boundaries, and both lead to high team cognitive load. And if the team cognitive load is largely exceeded, it also can become a delivery bottleneck. So we also need to analyze not only our architecture point of view, but also analyze where teams depend on other teams in terms of like other teams' activities or other teams' expertise, individual expertise to get our work done. So do we need to repeatedly hand over work at a later stage of flow to another team to get our work completed? So the teams of our online school solution are currently organized as functional silo teams. So when implementing or delivering changes, we have to hand over the changes from when we want to deliver and implement changes from front end to back end, we have to hand over the changes from the UI back end to the infrastructure teams in a repeated fashion. And handover require a high amount of communication and coordination efforts between multiple teams to implement and deliver changes. And if the teams cannot keep up with the demand placed on them, their work is piling up and causing then other teams, dependent teams, to wait, and their work cannot be completed and to be delivered. So they become a constraint, and the constraint can then dictate the system's overall performance. But we also need to mind potential efficiency gaps. And if the evolution states of the components we use in our organization differ from the ones that are available in the market, that might indicate an efficiency gap. We come to that one in a second. But as a summary, tightly coupled architecture, high team cognitive load, functional silo teams with repeated handover, high communication and coordination efforts between teams, delivery bottlenecks, efficiency gaps, that leads to a system which is very poorly equipped to respond to changes quickly and to absorb changes gracefully. So to increase our responsiveness to change, we need to optimize our system for fast flow of change. And to optimize for fast flow of change, that requires to manage our dependencies and constraints. So for example, a modular, well-encapsulated, loosely coupled architecture enables teams to move forward safely and quickly with a high level of autonomy and with a low level of risk to breaking other parts of our system. And with cross-functional autonomous teams, we make repeated handover redundant. And we can also minimize the communication and coordination efforts between teams. And a modular, well-encapsulated architecture helps to establish clear ownership boundaries and also minimize our team cognitive load. So eliminating constraints increases the system's overall performance, and closing efficiency helps us to increase our own efficiencies. So to increase the responsiveness to change, we need to design adaptive socio-technical systems that are optimized for a fast flow of change. And this can be achieved as one approach out of many by combining Wardley Mapping, domain-driven design, and team topologies. So let's go back together to the previous created Wardley Map and of our online school solution. And we use this as a visualized structure that guides us through our optimization process. So optimizing for fast flow of change requires to know where the most important changes in our system occur, the streams of changes. And the type of streams can differ in each organization, so they can differ between activity, task, role, customer segment, geography-oriented stream types. So in the current online school solutions, we are focusing on the activity-oriented stream types represented by the user needs of our Wardley Map. The users and the user needs, they are not only representing the anchor of our Wardley Map, but also represent the problem domain. And that's where domain-driven design comes in. So domain-driven design helps us to gain a shared understanding of our problem domain. And it helps us to partition also our problem domain into smaller parts, the subdomains. But not all subdomains are equal to the business. Some are more valuable to the business than others. So we have different types of subdomains. So the core domain, that is the essential part of our problem domain, providing competitive advantage. So that is the subdomain we have to strategically invest in most and to build in-house. And the supporting that subdomain, they support the core domain. So they do not provide competitive advantage, but they are necessary for the organization to succeed. And they typically exist in, are prevalent in other competitive solutions as well. So if possible, we should look out for buying off-the-shelf products or using open source software solutions. If this is not possible, if we have to custom build the supporting subdomains, we need to be aware of that we should not invest heavily in that part of the system because it does not provide competitive advantage. then the generic subdomains, these are subdomains that many business systems have, not only our competitor's solution, but many businesses. For example, authentication and registration. So they aren't core, provide no competitive advantage, but are necessary for the organization to succeed. So buying or using off-the-shelf products or using open source software solutions or outsourcing to utility suppliers should be applied to the generic subdomains. So in general, the subdomain types help to prioritize our strategic investment and support us in build, buy, and outsource decisions. So, but when we switch to the solution space, so far we have addressed the problem space, but when we switch to the solution space, the solution of our subdomains are currently all mingled together in a tightly coupled monolithic big wall of mud with a messy model and no clear boundaries. And Konstantin's law says that a structure is stable if cohesion is strong and coupling is low. So with high cohesion and loose coupling, enables the system to be amenable to change. And to achieve high cohesion, the one part of this law, we need to group related business behavior together at one place. And that's where bounded context from domain-driven design can help us with. So bounded context groups related business behavior together, and bounded context itself defines where a single domain model can be applied. And a single domain model can be applied and where a single domain model can live in. And the domain model itself that encapsulates a particular business logic of a specific part of our system. And the bounded contexts are also enforcing high cohesion and modularity. And so bounded contexts in general, they are indicating good domain-specific themes to split our system into smaller parts. And they also into smaller, modular, well-encapsulated parts, and they also serve very well as ownership boundaries. And we are going to address this when we come to the team perspective. So in designing bounded context and domain models involves a close collaboration between domain experts and development teams, and in order to gain a shared understanding of the problem domain. And there exists also different techniques that you can apply, like, for example, event storming, domain storytelling, example mapping, user story mapping, and far more. The other dimension of this, or the other aspect of Konstantin's law, says that we should aim for loose coupling. And so in this aspect, we need to analyze or assess our current system in terms of like change coupling between bounded contexts. So change coupling itself, that addresses how significantly the change of one part of our system will impact other parts of our system. And that's where context maps of domain-driven design can help us with. And context maps, they make change coupling visible. So context maps provide patterns to describe the integration between bounded contexts, and also they describe the inter-team relationships. So let's assess the coupling of the core domain-related bounded context in particular. So when we are, since core domain-related bounded contexts, they are providing competitive advantage, and they are strategically important to our business, and they tend to be quite complex and tend to change far more frequently than other parts of our system. So when integrating with core domain-related bounded contexts, we need to focus on loose coupling between our bounded contexts to avoid impeding the evolution of the most business-critical parts of our system. And to achieve loose coupling, when integrating with core domain-related bounded contexts, we need to make sure that the core domain-related parts can evolve independently. So we need to avoid exposing, and this for one scenario could be that we need to avoid exposing our internal core domain model to the outside. So instead, we need to establish a kind of translation mechanism. So the context map pattern open host service, that is one of those, that provides a public API to multiple downstream consumers, but it also offers a translation mechanism. It also offers translating the internal domain model to the external API. so that it helps to decouple the implementation of the internal domain model and protect it to be propagated, to be exposed to the outside, to the public API. And another thing is when integrating with a poorly designed upstream model, for example, when we need to integrate with a big ball of mud, with a messy model and no clear boundaries. Maybe that sounds familiar to you if you have to integrate with legacy systems that have evolved over a couple of years or decades. Then you would like to protect your core domain-related bounded context from a messy upstream domain model. And that's where an anti-corruption layer can help us with. So an anti-corruption layer that translates an external upstream model into an internal downstream model and protects the downstream model from poorly designed upstream models or from foreign concepts that we don't want to be propagated to our internal domain model of our core domain. But there could also be some problematic dependencies. So on one aspect, we need to avoid conforming to a volatile core domain when no backward compatibility is given. So the conformist, that's another context map pattern, that adheres the downstream model to the upstream model with no translation involved. And when we're conforming to a volatile core domain model or core domain related bounded context, and when that could cause a lot of change coupling to our downstream core domain model. So specifically when no backward compatibility is given. So conforming to a volatile upstream model then requires much attention to the source of constant change. And another aspect is that we need to minimize the duplication of complex core behavior. So with separate ways, that's another context map pattern, we are aiming to avoid integration and with other bounded contexts. For example, if an integration with another bounded context is too expensive, or if, I don't know, if the team relationship might be too problematic, then we go separate ways. But that has the side effect that we are duplicating some of the functionality when we go separate ways. And using separate ways with core domain related bounded contexts can then be very expensive because we are then duplicating a very complex core behavior on the one side, which needs to be updated at a very frequent cadence. So we should avoid that. And we also need to minimize competing change requests introduced by other teams. That is now where we come to the team relationship related bounded context, context maps. So in a customer-supplier relationship, the customer can gain influence over the upstream supplier tasks, priorities, plannings, and so on. And a customer-supplier relationship with a core could lead to competing changes or competing change requests by the customer. Or if you have a vetoing customer in place, I don't know if you maybe have experienced this when there's a lot of politics involved in your organization, that one team can block the changes of your API. So then we have a vetoing customer in place. And if you have a vetoing customer with a core domain related bounded context, that can then block the evolution of a highly business critical part of our core domain related bounded context. And with the partnership, teams are collaborating together towards a common goal, and the partnerships require a high level of communication and coordination efforts between teams. And especially a partnership with a volatile core domain that should be avoided because that requires a high amount of communication and coordination efforts, which then slows down the development and evolution of our core domain related bounded contexts. So context maps help us to make change coupling visible. And context maps also expose problematic dependencies that might lead to tight change coupling and can slow down our fast flow of change. And that is specifically critical if we are integrating with core domain related bounded contexts because they are the most business critical part of our system. So let's go back to our Wardley map. And as mentioned earlier, bounded contexts serve very well as well-defined ownership boundaries. And that makes the bounded context good candidates for team boundaries of streamlined teams. And that brings us to Team Topologies. Who has read the book Team Topologies from Matthew Skelton and Manuel Paes, published 2000? Few hands, awesome, so I can, something new to you, awesome. So streamlined teams were introduced by Matthew Skelton and Manuel Paes in their book Team Topologies. It was published in 2019, and I wish I have read this book a couple of years before. Because they provide very well-defined team types, interaction modes. So, and they introduce 4 different team types. And the one team type that the majority of your organization should consist of are streamlined teams, and they are autonomous cross-functional teams that are aligned to a continuous stream of work. And the streamlined teams, they are focusing on a fast flow of change. But to be able to produce a steady flow of feature deliveries, to be able to focus on a fast flow of change, the streamlined teams, they need to get support from other team types, for example, from platform teams. So platform teams, they support streamlined teams delivering their work, and they are responsible for platforms that can be easily consumed by streamlined teams. And the platform that the platform teams are responsible for, they can vary in its level of abstraction. So at a lower level, a platform can abstract away infrastructure, cross-cutting, networking capabilities. And at a higher level, a platform can abstract away, for example, a design system or a data platform and more. So the platform teams, they provide internal self-service services and tools that the streamlined teams can easily consume for using that platform that the platform teams are responsible for. Or these streamlined teams can get support from the enabling teams, and the enabling teams are acting as internal coaches and mentors in your organization, and they help to identify and acquire missing capabilities. So they are there to be pulled in on demand and to upskill your teams. Or the streamlined teams can get support from the complicated subsystem teams. That is an optional team type. And they are supporting the streamlined teams on particular complicated subsystems that requires very specialized knowledge, for example, face recognition engines and something like that. So the goal of those teams are to increase the autonomy of the streamlined teams and reduce the team's cognitive load of the streamlined teams, to enable a fast flow of change as an overarching goal of all team types. But to arrange this team is not enough to become effective. How the teams are interacting with each other and when to change and evolve the interaction is also relevant for organizational effectiveness. And that's where Team Topology has introduced 3 different interaction modes. So with collaborations, the teams are working very closely together over a limited period of time. And collaboration is suitable for rapid discovery, for example, when exploring new technologies together. And but the collaboration, this is important, is meant to be short-lived. Then we have X as a service that suits well when one team needs to use a code library, a component, an API, or platform that can be effectively provided as a service by another team. And it works best where predictable delivery is needed. And facilitation, this is the interaction mode that comes into play when one team would benefit from active help from another team. So this is typical for enabling team when they go into their internal, when they provide their help with internal mentoring. So as said before, the streamlined teams are relying on the other teams to support them delivering their work. And when we come back to our Wardley Map, we can now follow our value chain and try to identify services that are needed to support a reliable flow of changes that can form easily consumable X as a services. So in our example, the infrastructure component, product and rental or commodity and utility, they represent good candidates that can form a platform that can be then effectively provided as a service by platform teams. And the platform itself can start small. It can start with documentation, with standards, best practices, templates and can later evolve into self-services, APIs, and tools. It does not have to be fully fledged digital from the get-go. So the previous consideration might then result in this illustrated team constellation as a very simplified first draft, where the bounded contexts are handled by multiple streamlined teams. And as a side note, the one bounded context should not be owned by multiple teams. That would diffuse the ownership of teams. Instead, one bounded context should only be owned by one team only. However, one team can own multiple bounded contexts. And the infrastructure component in this example can then owned by multiple platform teams, by one or multiple platform teams. So, but we also, as we mentioned earlier, we also need to assess, analyze our potential efficiency gaps. And from the climatic patterns, we have learned earlier that everything evolves through the forces of supply and demand competition. And if the evolution stages of the components in our organization differ from the ones that are available in the market as commodity, for example, while we are custom building those, that might indicate an efficiency gap. For example, if we're custom building components in-house that do not belong to our core domain, which is very important, but equivalent ones are available as utility services, then we are lagging behind and we encounter potential efficiency gaps. And closing efficiency gap would increase our efficiency in our organization. And as we have learned earlier from the climatic patterns, then efficiency enables innovation. And one approach in our example that we can apply here is to close this efficiency gap by migrating on-premise infrastructure components with cloud-hosted services. But we are going to address this in a second. So now the question is, starting from our current landscape with a monolithic big ball of mud with messy model and on-premise infrastructure component, how do we then transition to a modular, well-encapsulated system with well-defined teams and cloud-hosted services? And the transition can be initiated by a team-first approach. So we can start organizing our teams first. So optimizing our system for fast flow of change is, in our case, in our example, led by dynamically reteaming the functional silo teams in platform and streamline teams first. And we are evolving then their interaction along a cloud migration journey. And the transition could start with forming a platform team first from the members of the previous functional silo teams. And they can then kick off the replatforming cloud migration strategy, the cloud migration journey. And with replatforming, the on-premise infrastructure components are going to be incrementally replaced with cloud-hosted services while we keep the applications architecture the same. And as a next step later, the streamline team can form, and the streamline team, the first streamline team can, or the streamline teams in general, they can then take care of the refactoring cloud migration strategy by refactoring the application. And with refactoring from the cloud migration strategy, we are splitting the application's architecture into smaller parts, and that's where we can reuse our previously designed bounded contexts as very well-defined modular boundaries, domain-specific boundaries. And the refactoring journey is supported by an evolution of team interaction modes, or team topology interaction modes. So the first streamline team can, at the beginning, closely collaborate with the first formed platform team and assess possible cloud options that are applicable for the future bounded context that the streamline team is going to be responsible for. And this close collaboration is to be short-lived, so that they're in the exploration mode. And this close collaboration can evolve then into limited collaboration and eventually become then later X as a service, where the platform team then provides best practices or standards, tools, or APIs to easily consume cloud services. And then the next streamline team can form and refactor their bounded context. And now they get support. The interaction mode between the teams can change and evolve. And now the new streamline team, the second one, can then get facilitation from the first platform team and the first streamline team. And they can share their knowledge and coaching them about practices that they have experienced during their refactoring journey. And we can repeat this with the next streamline teams as well. So then the next streamline team can form and get also support from the other teams, sharing their knowledge, best practices along their cloud migration journey. So in an ideal case, I have to say, at the end we can refactor our monolithic big ball of mud into a modular, well-encapsulated, loosely coupled architecture with bounded context. And we can form then our cross-functional streamline and platform teams and align their interaction to support a cloud migration journey in order to close efficiency gaps. And we can also, we could optimize our system for flow by minimizing the team cognitive load, by minimizing handover to other teams and minimizing the communication and coordination effort between multiple teams, and then it could eliminate our delivery bottlenecks. But we don't have to stop here. We can also create Wardley maps for internal users as well. So, we can, when we are creating Wardley maps, we can create multiple Wardley maps. So we can, for example, create Wardley maps for our external users, for our customers, so to have it more outwarding, but we can also create Wardley maps for our internal scenarios, internal situations as well. So, for example, when we switch to the X as a service perspective, then we make the streamline teams the users of the services that the platform team provides. And now the streamline teams, they have the user needs of building and testing, releasing, deploying, monitoring, operating, and provisioning their infrastructure and of the bounded context they are responsible for. And to fulfill the user needs of the streamline teams, the one scenario could be that the platform teams or multiple platform teams can provide a variety of X as a services. So, for example, a pipeline as a service, as a simplified draft here, can support the streamline teams to build, test, release, and deploy their services or bounded context, and it's also built on other components, version control system, and so on, and test automation. And also, to operate and monitor the services or bounded context, the streamline teams require then dashboard, alert mechanisms, observability capabilities, and so on, that can be then provided as monitoring as a service from another platform team. Or then platform as a service, infrastructure as a service then enables the teams, the streamline teams, to provision the runtime environment for the services or bounded context, including also the necessary components their services rely on during runtime. And as I said earlier, a platform can vary in its level of abstraction. So at a higher level, a platform can also abstract away or reflect a design system to achieve a consistent, well-defined visual language at scale. And the platform team owning this design system then can provide style guides, widget libraries, design principles as a design system as a service that the streamline team then can easily consume to design their own bounded contexts and services. And also, we might indicate some capability gaps. So there we are switching now from the X as a service value chain to the facilitation value chain. And that's where the enabling teams can come in. So the enabling teams typically do not own components, so they are pulled in on demand to upskill other teams. But I highlighted here on a Wardley map where their interaction is then valuable to other teams. And from the facilitation perspective, then the streamline team and platform teams become now the internal users. And cross-functional streamline teams, they have to cover a wide range of capabilities such as software design architecture, application security, UX accessibility, software development, QA and testing, product development, and much more. So that's a lot to cover where one single streamline teams might be very overwhelmed. And that's where the enabling team, with the specialists of enabling team, can come in and also can identify missing capabilities and acquire missing capabilities, upskill the streamline teams. And they come in on demand on specific cases. For example, enabling teams can coach streamline teams like about, for example, best practices of automated testing, so, and of course a lot of more. But also the enabling teams can facilitate the platform teams by coaching them about what is important to achieve a good developer experience when the platform teams provide their access services to the streamline teams, or what is important, how to design a good API, or how to write good documentation, right? It's very important. So plus the enabling teams can coach the streamline and platform teams also on other skills related, for example, on effective communication, on mentoring, improvement of practices, process improvement, and much more. But you might object, we are successful, why should we change? So that is fine, as long you have no competition, or your competitors are less evolved than you. Your competitors are lagging behind. But be aware that you might face inertia to change. And inertia to change created by past success is impeding the evolution of components. And it's not the lack of innovation that can kill an organization, but their inertia to change. For example, Nokia was very innovative. So they invented their first smartphone in 2005. That was 2 years before Apple came out with their first iPhone. But Nokia was still so successful with their old cell phone model that they were so reluctant to fully transition to the new smartphone era. So in I guess 6 years, their market shares dropped by over 90%. So being successful today does not mean that you stay successful tomorrow if the world around you changes. So when the market changes, unfortunately, you have to change too. Or maybe it's also an opportunity. I would say it's an opportunity. So investing in building adaptive socio-technical systems that are optimized for a fast flow of change, that equips us to thrive in the face of constant change. So we are now in a position not only to respond to changes that are introduced by others, but now we are in a position also to leading future changes introduced by us. For example, we can add additional differentiating values, increasing our competitive advantage, or we can be the first mover to commoditize components that others can innovate on. And then we can also identify usage patterns as sensing engines so that we can also then derive future components for industrialization again, kind of like innovation loop. And we can also build in corporations or alliances to accelerate the evolution of components and also growing our ecosystem. So now there are so many options available that you can pick from depending on our context, but now we are in the driving seat of change. So I might have exceeded your team cognitive load or the audience cognitive load a little bit. I'm apologizing for that, but I'm providing the slides at the end. But the good thing is you can start small. You do not have to apply all at once from the very get-go. You can start with those parts that are most useful to your own context. So I preferably personally like to start with a Wardley Map in order to generate a common understanding of your landscape you're operating and competing in, and using this Wardley Map as a structured way that guides you through the optimization process. But you can also start with your current teams and identify the current dependencies, bottlenecks, where do they have to, you can also complement this with value stream mapping, for example, as well. So it's like how to reduce your dependencies, inter-team dependencies, how to minimize your handovers. Or you can also identify suitable themes for modularization, and that's where, for example, subdomains and bounded context can help you with. And at some point, their paths eventually cross as architecture for flow. So coming to the end, so combining Wardley Mapping, domain-driven design, and team topologies helps us to understand the landscape we as an organization are operating and competing in, including also the external forces that impact our landscape. It helps us to anticipate changes and identifying potential points to invest in order to gain a competitive advantage. It helps us to gain domain knowledge and discovering our core domain, providing competitive advantage. It helps us to know what components to build in-house, where to buy or use off-the-shelf products, or using open source software solution, or outsource to utility suppliers. It helps us to establish a modular, well-encapsulated architecture with well-defined ownership boundaries, for example, with bounded contexts, and aligning our teams and not evolving their interaction to the system we build and the strategy we plan, eliminating delivery bottlenecks and increasing software delivery performance. So the combination of Wardley Mapping, domain-driven design, and Team Topologies, that helps us to provide a powerful holistic tool set to design, build, and evolve adaptive socio-technical systems that are optimized for fast flow of change, that enables us to adapt, evolve, and thrive in the face of constant change. And with that, I added some references that you can. And there's a lot more to explore, that I'm writing on right now. And thank you so much. I provided the link to my slide deck that you can download. And I'm looking forward. I don't know if we have time for questions, 2 questions. So I'm also around if you have some questions, please approach me. I'm happy to answer your questions. Thank you.
Thank you so much, Susanne.